Welcome to day number 15 of Learn Fusion in 30 days. Today, you'll create a 3D printable painter's tripod as you learn to loft to a point, practice constraints, and more. Let's get started. Start with a new hybrid design file and save your design. Hybrid will allow you to duplicate the model later for batch 3D printing. Remember, when using a hybrid file, always start with a new component. Activate New Component and name it Painter's Tripod. Notice the recent Fusion update makes the component an internal part by default, and you no longer need to choose part. Click OK to save the component. Painter's tripods, or pyramids, help you prop up items when you paint, stain, or glue them. This allows you to do all sides of a project in a single session. We'll first sketch the bottom triangle and then project geometry to create a point at the top to reference. Press L to activate line and start a new sketch on the bottom XY plane. Click to start the line and continue to click until you create a three-sided triangle, resulting in a closed sketch profile. Use the equal constraint to make all three sides equal. Activate Equal from the toolbar and select two adjacent sides. Then repeat this for the final side. Later on, we'll use the Circular Pattern tool to pattern the cutouts around the center Z-axis, so you'll want to center the triangle to the origin point. Activate Line again and sketch a line starting from the midpoint of one line, where the triangle glyph appears, and click to place the second point at the vertex of the triangle. Repeat this for a second direction, which provides us with an exact center point of the triangle. Press Escape to clear the line command. Hold the Shift key to select both lines and turn these into construction lines, as you will use them for reference purposes. To ensure you have a point to reference, activate the Point tool from the Create menu and click where the two lines meet in the center. Activate Coincident from the toolbar and select the new point, followed by the center origin. The point provided a snap point for us to apply the constraint that you otherwise could not apply. If you press Escape, you will find that our triangle will rotate freely around the origin. Add a horizontal constraint to one of the lines to force the triangle to stay in place. If you press Escape and test the movement again, the triangle will only increase or decrease in size. You followed the best practice of applying sketch constraints first, and it's now ready for you to dimension. Activate Sketch Dimension and apply a 50mm dimension to one side of the triangle. Remember, our equal constraint forces all three lines to remain equal, meaning this 50mm dimension drives all of them. This makes it easy for you to update later. The sketch is now fully defined, and the geometry turning black, along with the red lock icon in the browser, confirms this. To loft to a point, you need a sketch above the existing sketch. Similar to the Day 4 bottle, use the Offset Construction plane, which provides a plane to sketch on. Activate Offset from the Solid tab and select the bottom origin plane, since you know this origin plane will never move. To build more intelligence into your design, you can create a tetrahedron by adding the following equation. Start with D1 for our first dimension, an asterisk to multiply this by the square root of 6 in parentheses. You then need to wrap the whole thing in parentheses so you can divide it by our number of sides, which is 3. This will ensure the height is always driven by the single sketch dimension. Click OK to save the construction plane. Right-click on the new construction plane and select Create Sketch. To ensure the model is fully parametric for future changes, you'll want to reference the existing center point of the bottom triangle. You can do this with the Project command. Remember, intersect works great when the active sketch plane intersects the desired geometry. However, our sketch sits above the geometry, so we must use Project. With Project active, select the center point. Rotate the view as needed to ensure you selected the correct point. Click OK to save it and select Finish Sketch in the toolbar. You now have a point to loft to. Take a few seconds to follow the best practice of renaming your sketches in the browser. I won't do this in all the video tutorials for the sake of time and redundancy, but I do always take the time to rename them for my personal and client projects. Let's also test that the geometry is set up correctly before lofting to a point. Hold the Shift key and select the point and the base triangle. Notice in the lower right-hand corner, Fusion displays the distance between the two. Double-click the first sketch in our timeline and edit the dimension. Change this to 100 millimeters and select Finish Sketch. The equation drives our offset plane and the sketch point will always be at the exact center. Hold Shift and check the distance again. Notice everything correctly doubled in size. Press Undo until the dimension is back to the original 50 millimeters, and then select Finish Sketch. Activate the Solid Modeling Loft command. Very important, be sure to activate the blue Solid command and not the orange Surface Loft command. During the Complex Glass Bottle lesson on day 4, we looked at lofting with 4 different closed profiles. The Loft command also allows you to loft to a sketch point instead of a closed profile. Select the base sketch profile, then select the sketch point. This completes the basic pyramid shape, which is driven by a single sketch dimension. Click OK to save it. To make this better for 3D printing, activate the Shell command to hollow out the pyramid. Select the bottom surface and define the thickness as 2.5 millimeters. Remember that selecting the bottom will remove the bottom surface. This is desirable to make them stackable for storage. However, you could select the entire 3D body if you want to 3D print a version that is 4-sided. Let's cut out material from the 3 sides to reduce wasted filament. Right-click on any one of the 3 faces and select Create Sketch. When you have existing 3D bodies, this is the fastest way to create a new sketch on an existing face. Once again, you will want to project or intersect the existing edges to ensure the sketch inherits any changes in size. In this case, both tools would produce the same exact results, and intersect is possible since our active sketch plane sits on the surface. Press P to activate Project and select the middle of the triangle, which will automatically project all 3 outer edges. Click OK to save it. Let's then activate the Offset tool to create a triangle cutout. Select the outer edge and define the distance as -6 millimeters. Press E to activate Extrude and select the inner triangle profile. Remember, to build intelligence into the model, you do not want to simply type -2.5 millimeters. Instead, switch to the To-Object Extent type and select the inside surface. This will ensure that the extrude always cuts to the inside, even if you later change the shell thickness. Click OK to save the extrude. You can now activate the Circular Pattern tool. Set the object type to Features, which allows you to select the extrude in the timeline. For the axis, select the existing Z-axis. By creating the pyramid centered to the origin, you can leverage the existing axis. For future reference, if you sketch away from the origin, you could always leverage the construction axes, which are similar to construction planes. The quantity will be 3, providing 1 for each side. Change the compute type to Optimized, which is the fastest and consumes the least amount of processing. If it doesn't work on your computer, try using the Adjust option. Lastly, add a 1 to 2 millimeter fillet to the top 3 edges of the pyramid. You can also add fillets to the inside cutouts if desired. Have some fun and experiment with different fillets. Let's now leverage our component to create copies. One of the easiest ways to create duplicates for batch 3D printing is to use the pattern tools. Very important, notice the anchor icon on the component. This means Fusion grounds or locks it to the parent level component. Right now, you cannot click and drag the component. Right-click the component and select Unground from Parent. This removes the automatic lock that anchors a child component to its parent component. Doing this before you pattern will allow you to move around any patterned instance. Activate Rectangular Pattern and use the Component object type. This allows you to pattern the entire component. For the Axis selector, select the bottom X or Y axis and drag the directional arrows to start the pattern. Here's a pro tip. Most overlook that you can reference dimensions inside the pattern tools. Set the distribution to spacing, and then define the spacing as our D1 dimension. You can also add a clearance to the spacing. Define the spacing for both axes and choose the desired quantity. If you want these nested differently, you can click and drag them around. There are a few ways to tackle this. What do you think is the most efficient way to nest these triangles? Let me know in the comments. Great job completing the painter's tripods. I'll see you on day number 16, where you'll learn how to create user parameters to drive your designs.